Yeah. So in this sum, firstly we need to find the integral of the function with respect to z. However, we are given the function in terms of x and y. So the first logical thing to do would be let z is equal to x plus iy. Okay, so we basically do a substitution, simple one. Then since we know that y is equal to 2x square, we can substitute that in here. We'll get z is equal to x plus, if we substitute that here, we'll get 2 iota x square. Okay, now if we differentiate this thing, we'll get dz is equal to dx plus, if we differentiate 2i, it's a constant, so only x square ka differentiation is 2x, 2 2s are 4 iota x, and we'll get a dx here as well. Now dx can be taken common now, so we'll get dz is equal to dx 1 plus 4i. This is our substitution. However, we also need to keep in mind the limits. We are given the limits for z to be from 0, which is basically 0 plus 0i, to 3 plus 18i. But now we are going to be transforming this function into terms of x, as so. We basically just substitute y is equal to 2x square. So wherever we see y, we'll just write 2x square over there. So now f of z becomes x square minus 2 iota x into, we see a y here, no? So we put 2x square. So then we get x square minus 4 iota x cube. This is our new function. Nice, sir. And similarly, for the limits also, we need only the x term. We took z as x plus iy. See, x plus iy, x plus iy. Yeah, but we only need the x part now, because we converted the function into x, no? You don't see any y here. So if we had the y also, we couldn't substitute it anywhere. So our new limits for x become from 0 to 3. Nice. Now we can rewrite the integral as let I is equal to integration limits from 0 to 3. Now our f of z becomes x square minus 4 iota x cube into, this part becomes 1 plus 4i is a constant, and into dx. Now if you want, you can multiply this or take the constant outside as well. Doesn't really matter. Oh wait, this thing is not a constant. We had this x, no? I forgot. This is not a constant. Nice. So now if we multiply this inner part, we'll get x square, then x square into 4 iota x plus 4 iota x cube minus 4 iota x cube into 1. So minus 4 iota x cube, then minus 4 iota x cube into 4 iota x, which will give us 4 4s are 16 I square into x raised to 4, and still we have a dx right here. Now these two terms get cancelled. I square is minus 1, so minus minus will become plus in the next step. We get 0 say 3 x square plus 16 x raised to 4 dx. Nice. So now we can just integrate this normally. There's no z and stuff now, so it becomes very simple now. Normal integration, x cubed by 3 plus 16 x raised to 5 upon 5, and limits are from 0 to 3. When we put 3 here, we'll get 27 upon 3 plus 16 into, this will be 243 if I'm correct, upon 5, and the lower limit would be just 0. Now we could just solve. Hey, had to retake this because of a calculation error. I'll just use the calculator from next time. So we get 27 by 3 plus 16 into 243 upon 5, which gives us 3933 upon 5. 78 is 786.6. This is the answer of our integral.